Alrighty, I want our serializer to also support nullable values and also nullable reference types. Now, our system really doesn't serialize many reference types, although we'll see very shortly that we will be able to using a custom serializer. But I want to go ahead and write a support in for creating nullable ints and nullable floats, for example, and also passing null strings. So, to do that, I'm going to jump into our tests, and I'm going to write a couple tests. And I'm going to write a test for some nullables, and I'm going to write a test for strings. So I'm going to say test. I can't even type today for some reason. Public void can read and write nullable value types. So I'm going to say var ser equals new simple serializer. And then I'm going to say test serializer bw, and I'm going to say bw.write, let's say, let's create some integers outside of here. So I'll say int1 equals 1, 2, 3. Then I'm going to say int question mark int2 equals null, int question mark int3 equals 4, 5, 6. So now that I have these three values, this is going to be my test data. So first I'm going to write int1, or sorry, I'm going to say serializer.writeObject binary writer type of int int1. I'm going to say serializer writeObject bw type of int nullable int2, and then I'm going to do the same thing on the third one, except do that. Okay, so then I'm going to add another argument in here for our test serializer invocation, and I'm going to say serializer.readObject, passing in the binary reader, and type of int should be int1. Serializer readObject br type of int nullable should be null, and serializer readObject br type of int nullable should be int3. Okay, so that's the first test case. We want to be able to support nullable ints. Then I'll just go ahead and write the string test here too. Can read and write null strings. So I'm going to say var ser equals new simple serializer. I'm going to pass in var stir1 equals hey, and then string stir2 equals null. And I'm going to say test serializer bw goes into bw or ser write object bw, passing in type of string, and then passing in stir1, and then I'm going to do the same thing and pass in stir2. Then I'm going to do a br. I'm going to say ser.readObject br type of string should be stir1, and ser readObject br type of string should be stir2. Okay, so let's go ahead and run these tests, and as you'll notice, they're going to fail because, for example, it doesn't support the nullable type, and this one should fail as well. And it manages to work. Oh, derp, I ran the wrong test. That's the right test. Yes, this one fails too. It says value cannot be null, parameter name value. And that's for our write method that we're invoking on our binary writer. Okay, so now that we have that all set up, let's go ahead and do our nullable value types first. So how do we do that? Well, what we're going to have to do is we're going to have to detect if an object is nullable when we write it or when we read it. And we're going to have to write in and or read an additional Boolean value that'll indicate whether or not the next couple of bytes are null, whether or not it constitutes a null object. So you can imagine if the stream would look like this if it had 3 integers, right? You know, if the stream had 3 integers in it, this is what it would look like. Well, now let's imagine that the first integer is the same, but the second integer is now a nullable integer. Now it's going to say true that, and then let's say the third integer is a nullable integer that is null, so that'll look like this. So if we delineate the individual components of the stream, we'll see that. So basically we're adding on an additional Boolean in the stream to indicate whether or not the next value is going to be null. And I don't want to do this all the time because it would add an incredible amount of unnecessary overhead to the size of our stream. So I'm going to have to add some logic that'll only write this additional Boolean if it's a nullable type. And specifically, if it is not a value type or if it's a system.nullable. So now for a little background on what system.nullable is. So you guys might be familiar with me being able to say this nullable int equals null, for example, right? So what does this actually do? What does this question mark do here? Well, it's interesting because it actually expands to this. So these two lines are actually equivalent in every way. So if you look at the nullable type, you'll see some additional parameters that are, or some additional properties that are added to the nullable type to facilitate in marking value types as null or not. So just a quick recap, you have reference types and you have value types, and value types cannot be null, whereas reference types can. But if we wrap up our value types in a nullable, then we are able to represent values as null. What I find particularly interesting about the nullable type is that it's a structure. So the nullable type itself is indeed a value type, which is interesting. So you might be saying, well, if the nullable type is a value type, how can it be null? And the answer to that is that it can't be. This is actually a special type that's recognized by the C# compiler, and it'll actually expand out these assignments of null to this nullable type and just simply instantiate a nullable object with a bit flipped in it that indicates it's null. In addition, if I were to do something like if nullable int does not equal null, what that actually turns into when the compiler sees this code is if nullable int dot has value. So just a couple interesting things to point out about what the nullable type is. And they're important to know because we need to know how to detect nullable types in order to write custom serialization logic based on whether or not the value type is nullable. So to do that, we need to be able to detect if the type coming into this writeObject method is a nullable thing, and we need to extract out the thing it is nullable for. In this case, an integer. Then what we do is we tack on the additional Boolean indicating whether or not the value exists or not. And if it does exist, we go into our write simple and we write out the value. Okay, so now that we have that background out of the way, we can now determine if an object is nullable or not. So what I can do here is I can say var is nullable. Well, let's actually first handle one case before it. How do we handle the case if the value that's passed into writeObject is null? It's actually very simple. We can, if I say if value is null, we can say writer write false return. And this covers everything. There's no special logic that we need to write to handle nullable types versus reference types here. If the value is null, we know the type is capable of being null, so we know we can just write out false. So next up, we need to determine if the value type is nullable, because if the value type is nullable, then if it's a reference type, if this value object is null, or if it's a reference type, if it's nullable or a reference type, we need to write true to the stream to indicate to the reader that there is a value coming up. So what I'm going to do is I'm going to say var is nullable value type equals type is generic type and type get generic type definition equals type of nullable opened. So this is the open form of the nullable generic type, meaning I did not provide any generic type parameters to it. So now what I can say is if the type is not a value type or the type is a nullable value type, then writer write true. Because at this point in the method, we A, know value is not null, and B, we have determined if it's a nullable value type. And finally, we could also determine if it's a value type or if it's a reference type. So to determine if a type is a reference type, we simply negate the isValueType property on it. Okay, next up, now that we have this information, we need to do something special if the value passed in is a nullable type. So if it's a nullable integer, for example, we need to extract out that generic parameter. Remember, the type we might be getting in is nullable of int, or maybe it's nullable of float, for example, right? We need to extract out this type that was used in order to write the simple form and serialize the simple form of the value that was passed in. So what I'm going to do is I'm going to say if is nullable type. Then I'm going to make sure that down here I add an else. This is important. I'm adding a new clause to my kind of switch that I have here, which is if it's a nullable value type. And so it's important that I add the else if right there so that it continues on the chain and I don't get a double write. So add that else in there. So the isNullable value type, what I can do here is I can say write simple, passing in our binary writer. Then what do we pass in for type? Well, we simply pass in type, get generic type arguments at index 0, and then pass in value. So this will extract what the thing is. So if type is a nullable of float, for example, this will extract the float portion of it, as you can see right there. Okay, so we pretty much have our writing down. So I can run this test again. The test will still fail, but we can track our progress by seeing where it failed. Previously, it failed during the write step. Now we can see that it freezes Visual Studio. There we go. It says expected object be hey, but found empty string. So now we see that we've gotten past the right part, so we know we're making progress. So now let's go ahead and write basically the opposite of what we just wrote in the read portion. So I'm going to scroll up here to scroll down here to our read object. And what I'm going to do here is I'm going to say if not type dot is value type, if reader dot read boolean is false, return null. So what I'm doing here is I'm saying if the type is a reference type and we read the boolean and it's false, that means this object or this value is null, so we return null. Otherwise, if it is not a value type, we need to determine if it's a nullable type, and we're going to do the exact same thing that we did before. I'm going to say else if type is generic type and type get generic type definition equals type of nullable empty. Then I'm going to say if reader read boolean is false, return null. Otherwise, we are going to return, or actually, return null. I actually don't think that'll work. Yeah, see, this isn't going to work. Because remember, this is actually where it's important to understand that system.nullable is a struct and not a and not a reference type. We can't actually, won't be able to properly cast null to that value, I'm not thinking. Let's just leave it like that and see what happens. I'm actually curious. Okay, so if a read boolean is false, return null. Otherwise, return read simple. And I'm going to pass in our binary reader. Then I'm going to pass in type.get generic type arguments 0 to extract out that type. All right, let's see what happens here. And we get a test pass. So if we run everything, and we can read and write strings now too. Okay, so I am a little bit curious about how that works. I mean, I'm sure actually what's going to happen is since we're going to have to do a hard cast anyway. Yeah, actually, I wonder if I come back here and the can read and write nullable types, instead of saying this should be null, I'm going to say this should be int2, which is an important distinction here. Well, let's see if that fails the test. No, it doesn't. All right, so it seems that the .NET is handling the nullable types very gracefully, so that is a good thing. What is it yelling at me about this? Convert to constant. No, I don't want to convert it to constant. Okay, so that is nullable types. Let's also go ahead and see if it handles nullable arrays first, or last. The last thing I want to do. Public void can read and write arrays with null values. So I'm going to say var sir equals new simple serializer. I'm going to say var r equals new hey null stuff. Then I'm going to say test serializer bw serializer write object, passing in our binary writer, a type of string array, and a value of array. And then a br, and then I'm going to say var read r equals serializer read object, passing in our br, type of string array, and I'm going to cast it to a string array. Then I'm going to say read r dot length should be r length for var I equals 0. I is smaller than read r dot length I plus plus. And then we're going to check to make sure that the individual elements match up. So I'm going to say read r I should be ri. Hit run and see what happens. And we get success. So now we can support null values in arrays of reference types, which is cool. Okay, so you might be asking what the value is of supporting reference types if thus far we've only been actually adding support in for value types. In fact, the only reference type that we so far support are strings. And the answer to that question is that there are going to be some scenarios where we will need some sort of more powerful serialization, some sort of custom serialization that doesn't rely on this really basic system. Now, I'm really wanting to write a serialization framework that actually does perform all of this stuff for you automatically, but unfortunately that's going to that would add a lot of overhead to this chapter. So instead what I'm going to do is I'm going to allow the possibility for custom classes to be serialized if they implement a special interface. So the special interface will allow them to, well, do their own custom serialization if they wanted to. In addition, I also want to support polymorphic serialization. And what I mean by that is I want to have a method that takes in an interface and is able to be satisfied by a variety of different concrete types and have the proper concrete types read in at the other end. But let's just focus on custom serialization for now. So the custom serialization is really just a matter of having a special interface and then adding some methods to it. So what I'm going to do is I'm going to come up here to infrastructure and I'm going to add a new interface. I'm going to say I custom serializer. So the I custom serializer is going to have a void save binary writer and a void read binary reader. In fact, we might be able to also throw in a I serializer parameter as well. Now the reason I'm throwing this parameter in with the save and the read, actually it should be save and load. You should always keep your words sort of in the same sort of category. What I mean by that is if you have a save method, you should have a load method. If you have a read method, you should have a write method. But anyway, So we have our save and load methods, and I'm taking in a iSerializer so that we can take advantage of the other methods on the serializer to perform additional serialization. For example, serializing a whole array. We wouldn't have to do that manually in this case. Okay, so now that I have this interface, I actually have all the code I need to write in order to write my tests. So I'm going to go ahead and write just one basic test. I'm going to come up here to our simple serializer tests, and I'm just going to scroll all the way to the top, and I'm going to say class component1 implements iCustom serializer. And of course, the iCustom serializer is going to have two methods on it, our save method and our load method. Now the component one, another constraint is going to be that it requires a default constructor, which I don't even need to provide one, of course. Then I'm going to say public int1 get set, public float float2 get set. And this is just to simulate something, some sort of custom serialization. So now I'm going to say, for save, I'm going to say writer write int1, writer write float1 or float2. Let's call that float1. That makes more sense. And then for load, we're going to say int1 equals reader read int32, and float1 equals reader read single. So basically, we're just simulating a custom class that we might want to send over the wire, but have it support its own serialization. Okay, so now that we have that done, let's write a test for it. So I'm going to scroll all the way to the bottom, and I'm going to say public void can read and write custom object. Say varser equals new serializer, oops, simple serializer, and then I'm going to say var component1 equals new component1, and I'm going to initialize his float1 to 3.14 f, because why not? And it's int1 to 256, because I like those numbers. Okay, so then we're going to say test serializer, passing in a br of, br goes into ser.write object, bw, type of component1, and a value of component1. And then br, we're going to say var read component equals serializer read object binary reader type of component1. Then I should also say read component should not be null for 1. Read component dot. Whoops, I have to do a cast here. So I need to make sure that I cast the return of ser.readObject. So I'm going to say int1 should be component1 dot int1. Read component dot float1 should be component1 dot float1. All right. So now that we've done that, let's go ahead and run our tests, and we should get a big error. And we do. Cannot write a simple serializer component1. So now let's jump into our simple serializer class and actually add support. So what I'm going to do is I'm going to basically write a I'm just going to write a little helper method down here at the bottom. So I'm all the way at the bottom of the class. I'm going to say private static bool is custom serializer. Type. So I'm just writing this little private one-line helper method. The JIT will probably just inline this method anyway, so we don't get any performance impact of separating this out into a method. But since we're going to be using this in two places, I figured it would be a little bit cleaner to turn this into a method. Basically, it's just going to say return type of iCustom serializer is assignable from type. Now we could speed things up with maybe a hash map of all known custom serializers, but we're not going to do that. Okay, so now that we have our isCustomSerializer method written, we can jump all the way to the top to our write object. So after isEnum, I'm going to do this after isEnum. I'm going to say else if is custom serializer type. And if it is, then, well, I need to go ahead and write it as a custom serializer, which is really easy to do because I simply have to cast it into an iCustom serializer like that and say save writer. And that's it. There's nothing else that I need to do. Remember, I've already taken care of the possibility of value being null from the top. Oh, and of course, I also need to, because I added in the iSerializer parameter, I also need to provide this as well. Let's get rid of those curlies. Okay, so now that we've done that, we need to handle reading from a custom serializer. And so that's going to be pretty much the same process. I'm going to scroll all the way down to read object, which happens to be the next method. After if type is enum, I'm going to say if is custom serializer type. Then I'm going to say var value equals iCustom serializer activator dot create instance type. Then I'm going to say value dot load reader this, then say return value. So this is a potential issue as far as performance goes. The activator create instance method isn't the fastest method on the planet, but since I don't plan on having many custom serializers, I'm not going to worry about this. When we do go out and actually write a really nice binary serialization framework, that'll do that all with, really quickly. But since we're now relying on the reflection API, it's going to be a little bit sluggish. But fortunately, again, we're not going to use this very often. But when we do need to use this, it just makes things so much easier because you're not restricted to having a, let's say, or you're not forced to have a method that has 10.5 billion parameters because your serialization framework didn't let you write your own custom serialization. So that's really what we're trying to get here. So let's go ahead and run. And wait a year. And it works. I actually want to make this a little bit more interesting. I'm going to scroll up to my simple serializer tests, and I'm actually going to toss in a public string array. I'm just doing this to make this a little bit more interesting, because what I want to do is I want to see if I can properly use the iSerializer that's passed in. So I'm going to say serializer write object writer type of string array, and then I can also say string array equals serializer read object reader type of string array. Of course, I'm going to have to cast it to a string array as well. Now, I could provide some extension methods on this that will allow us to use generic type inference for our write and just normal generics for our read, which would make this a little bit cleaner. Not going to worry about doing that. So now I'm going to scroll all the way down to the bottom here and just update my test a little bit. I'm going to say string array equals new hello world and null and blah. Okay, again, this isn't vital for what we're writing. I just want to just see if this works properly, which it should. There's no reason why it shouldn't. Read component, of course, there's no reason why it shouldn't, are some very famous last words. String array dot length should be component 1 string array dot length for var I equals 0, I smaller than red component string array dot length I plus plus red component string array at I should be component 1 string array at I. And of course it passes. All right, so yeah, we now support nullable values, and we also support custom serializers, which again is really important because things can get really ugly if you don't allow this sort of extensibility. So there's really two more things with the serializer that I wanted to put in place before we moved on to other things, and that is the ability to write polymorphic types as well as the ability to write binary JSON. But we'll pick up on that in the next couple of videos, and we'll see you guys later.